So we'll continue. We are back. We are back. So I hope yeah, everything. I hope everything is working. You can hear us, you can see us, and the next example will be very interesting from two aspects. In the first aspect is that we'll be using time-dependent analysis. For the beam like this, which are pre-stressed, it's like essential. It's like essential to have the construction stages, because the concrete is undergoing the aging, so it means it's changing the material properties in like during the whole life of the structure, and you need to catch the point, catch the stages which are important for checking. And there is also some changing of the stresses in the tendons. There is like the evolving of the strength of the concrete. Yeah, so this effect has to be captured by the designing of the pre-stressed structures generally, not only for prefabricated structures. This is valid also for bridges, and so for all the structures. So this will be the first example where I would like to show you how to design and co-check the pre-stressed beam with using construction stages analysis. And later on, we'll export this beam to application IDEA StatiCa Detail, because there will be some many openings. And if you in the 1D model, or in the model which is composed from the beam elements, you cannot put the openings. Yeah, so you need to use some, let's say, more advanced approach, or some wall elements, some shell elements that where you can put the openings and run the analysis. If you put there the openings, there will happen some decreasing of the stiffnesses, because the section is affected with some openings. So there is the reduction of the material, so the stresses will change. There will be also, because it's opening, there will be some concentration of the stresses, which you need to somehow handle. And if you will do it by 1D element or using the beam elements, it's not possible to capture it. And I will show you the power of this beam link between our two applications, this interoperability. So I will just keep the Eurocode standard. And what about the design working life? You know that for the beam like this, we are expecting the 50 years, like the end of the design working life. But for the bridges, you will select 100 years. Yeah, so we're staying by the civil structures, the halls. So it's a beam. The cross sections which you will select can be designed by the advanced library that is here. We are like recognizing between the basic cross sections that can be used, between some advanced cross sections that can be used, and some composite sections. Generally, if you don't find the sections in the library, there is the option of the general concrete section that you can import whatever shape you want from the DXF. Perfect. So we will use this I shape with haunch flanges. And what about the dimensions? I will put there the dimensions, and you will see how the cross sections will change. So there is a 500, 320. It's like a bottom width of the flange. The total height is 1.2 meters. Here is 120, 30, 180, 30, and 160. So I have very easily created the section using the parameters that are described on the figure here. From the material properties, you can just hit the pen, and you can see here is some more parameters that can be changed. Maybe this is the answer on the questions that been put off. That been put off on the chatter. That here is also some class cement class that is very important for like evolving of the strength, because the concrete class is the rapid, you know, so it will have a different properties of the cement. So right now, if we are handling with the construction stage analysis, so this makes sense and it's very important to recognize it. So you can see the parameters, also the aggregate types like limestone, sandstone, basalt can be used for the calculations and will somehow affect the generally the behavior of the concrete, the evolving curve of the concrete from the point of view of the creep, from the point of view of the shrinkage. So these parameters are here right now. Okay, so I have created a section, and right now here is a very simple tab for putting the loads. This is like a, I would say it's like a initial conditions or initial setup for putting the loads. So we consider the self weight according to the cross sections. Yeah, it's same for every application or every FEA softwares. But from the point of view of the permanent and the variable loads, you can use here only the uniform loads, but mostly uniform loads are used for this type of the structures. Of course, if I jump into the applications, I can select, as you can see on the left side, there is some point forces, point moments, uniform loads, line loads, settlements, or user-defined forces. You can select more, but for your first pre-design, you can use like this option, permanent load and variable load, and you will put there only some intensity. My intensity is 9 kilonewton per meter for permanent load and 20 kilonewton per meter for variable load. If I continue to the next stage, right now I'm approaching the construction stage analysis, and what I will be putting here. We have strictly predefined the construction stages for the casting, prestressing, storage yard, transport, and final supports. In the service stages, we have predefined 2: superimpose dead load and end of design working life. But you as a user can put more. You cannot change the first paragraph like a casting, prestressing, storage yard, transport, and final supports. It cannot be changed. It's hard coded. But what you can put more construction stages to the service stages. So from the point of view of the pre-stressing, I know that my structure will be pre-stressed in the 5-day, and I have the option to select pre-tangent or post-tangent tendon. This structure will be pre-tangent with the pre-stressed tendons. From the point of view of the storage yard, I have also the option to use the post-tangent tendons and also some additional stressing or additional tendons in the final supports. This is like a multiple options for pre-stressing of the structures. What does it mean L1, L and L2? So it's very good to explain it at first that if you have the beam, if you have a beam like this, and here are the supports. So this is generally my length L, and L1 and L2 means the shifting of the supports at the beginning and at the end. So if I draw the scheme, so this is my L1, this is my L, and this is my L2. So right now you can see how, because the supports are changing during the construction stages. If you have a storage yard or transport, you can maybe put there more supports because you are transferring the beam from one place to the other. So we are using the N. So it means this is how many supports you would like to have on the beam. Yeah. So this is just the brief explanation to make it clear. I would like to shift my support about 1 meter from the left and the right side, and for transport there will be the distance will be increased about the increment of the 1 meter. So there is a 2 meter from the left and 2 meter from the right, And in the final supports, I would like to place back the supports to the location at the end of the beam. So there is a 0. So it means this is my length in between the supports is 16 meters. From the point of view of the superimposed dead load, so I can keep it as in the 60 days. And end of the design working life is in the 50 years, which is represented by the 18,250 days. So if you let's say miss something here, you can change it in the application. Yeah, don't worry about it. Okay, so I will finish it. And what you can see, I'm inside the application. In the application, you will see what we have predefined during the wizard workflow. So what I need to do, I need to change the beam for a haunched beam. So go to the cross sections. In the cross sections, we have predefined the section that looks like this. But I know that in the middle of the beam, there is a high 1.2 meters, but at the beginning is only 800 millimeters to create a haunch. So I will go immediately to the members. Let's say right now you know that you don't want to have a simply supported beam. So if you add another member, so you can see you can very easily create the continuous beam, very straightforward, very easily. How you can do it. Right now, let me create the haunch. If you would like to create the haunch, there is the feature that will help you. So the haunch will be symmetrical, but don't have to be. Yeah. So, but I know that it will be 8 meters from the left and the right side, and at the end, the height will be 800 millimeters. So I need to create a new section. The new section, the software remember your predefined settings, and you will just change from 1.2 meters to 800 millimeters. So I have created the haunch beam very easily, very smoothly, and I can approach to tendon design. In the tendon design, this is like a link, like a plugin to this application that will open up another level of the application. It means you have the option to design the tendons. It's like a tendon designer. Yeah, it's written there. So I'm opening the application, and yeah, this is like a scheme, how the creep and how the elastic response of the structure works over the construction stages. So you can see that I have, let's say, 7 construction stages, and these red curves representing the elastic increase. Yeah, generally, this is you will put there some loads. So this is some increment of the load. And over the time, there is happening on the structure something. And what is something? Something is a creep, it's a rheology. So, and the rheology is like increasing or changing the strain response that is there. Yeah, so this is schematically representing how the creep and the shrinkage is affecting the load cases. From the point of view of the tendons, this is what I would like to put there. So the tendons, you can use a pretangent on the edge and pretangent on the line. What does it mean? If I will use pretangent on the edge, and I will display this section, and I will use pretangent on the edge, so the software automatically created a 2 group of the tendons, and you are playing around with the numbers over the edges, and you will just put there the tendons wherever you want. I would like to show you different strategy or different option, so I can very easily delete all and create pretension in the line. So the settings will be looking similarly, but there is the option to like put the tendons using the coordinates. Maybe sometimes it's better to use pretension on the edge. Sometimes it's better to use a pretension in the line. I think it's dependent on the taste of the engineer. So I like use both, but more inclined to pretension on the edge. But this is only my personal experience. So if you create a tendon and you will check it in the 3D, so you will see this is my 3D rendering of the tendons that are inside the section. So you exactly know if your tendons are out of the section or not. And you can play around with a tendon geometry. So I will just go to the tendons or to the section. And before I go further, I would like to mention that if you select the tendon, there will create, it's automatically inserted to the load case number 2 that is called pretensioning. From the point of view of the material properties, as a default is this tendon properties. It's like a Y 1860 S7 with diameter 15.7 millimeters of the strand. So if you just hit the button here, so you can see what parameters can be changed. For me, about the relaxation, let's say we are using the low relaxation tendon as a default. And what is very important for you as engineers is a diagram. So you can select between bilinear with an inclined top branch or bilinear with horizontal branch. So we are using as a default with the inclined branch because there is more bearing capacity, of course. But maybe in some countries, you are used to it with horizontal branch. So it's up to you to select. Okay. And right now, the initial parameter that is very important is the initial or the anchorage stress. Yeah. So I can put here 1,400. This is my initial stress. And you can see the software also tells you the limit stress that can be used. So this is my inputs, and I will go to the pretension group. In the pretension group, I know that there are 2 tendons, but I would like to have 4. So I will put here, just stretch up this window, and there will be 4 tendons. I can draw the lines to see what is happening. So this is my cover, 4 strands in a layer, and the distance or the cover will be 50 millimeters. So I will just change the coordinates, the increments, like a 50 and 50. And in the vertex 7, you can see it's related to the starting and the end point. And my end point is the point number 7 or the vertex number 7. So it will be minus 50 and 50. And what about this parameter? We call it blanketed length. I think better description is like a debonding length that will tells you what distance from the beginning of the beam you would like to start to have the increasing stress on the rebars or the anchorage stress. So I know that for simply supported beams, you don't want to have some big bending moment in the beginning and at the end of the beam, because it will gives you some cracks in the top flange. So you will reduce the bending moment using this option, using this debonded length. So I will show you how it looks in the uncoiled view. So if you put there 2 meters, okay, so you can see some thicker red line. So the stress will start growing up at this point, not from the beginning, but from this point. Okay, so this is what I want. And right now I would like to have the same properties and same layout, but shifted only by the offset of the 50 millimeters. So you don't need to start from the scratch. You will just use this copy option or move it. We will use the copy option because we like to copy it, not move it. Just copy. You can see this is my Z and the Y direction. So here is 50 millimeters to the top. And that's it. You can see I have created the second layer of the tendons. If you check it in the 3D, so it looks like this. So I think I have defined everything. And right now, I would like to know what is the linear stress along the length of the beam, because we are in this analysis. Before you go to the final check, you should be aware if the structure is able to carry the load, or if the stress is not so high, and so on. So you will run this linear analysis to get the information about the stresses on the beam. Okay, so I will come back to the tendons. You can see it's keeping or retain the predefined properties. And I will go to the force design method. I strongly recommend you use the linear elastic stress. And if you run the calculation right now, you will see what is the stress in the bottom and the top fibers. So you will exactly know if you have a concrete C35/45 and the stress will be, let's say, 40 megapascals. So you're over. This beams is full, is like overloaded by the pre-stressing. Yeah. So based on this analysis, you will exactly know. I will just show you in the result classes. There are the two combinations which I consider for the calculation. The first one is at the beginning of the construction stage process. So it's in the second construction stage where it's acting only the self-weight and the pre-stressing. So you need to check if the stresses are not exceeded for this construction stage. And for the last construction stage, this where is self-weight, rheology, pre-stressing, variable loads, and the permanent loads for characteristic combination. So this is my combination, and I will run the analysis. This is like a pre-designed tool that will help you to identify where the maximum stress is and what is the magnitude. So if I check, so this is my envelope of the stresses. So I can see that the maximum stress here is 17.2 megapascal. So I think it's feasible to do it. And the stress in the tension by the top fibers is 3.2 megapascal. So if you have concrete C35/45, so the FCTM is, I think, lower than, or it's 3.2 megapascal or higher value. So it won't be ruptured, let's say. Yeah. So it will help you to identify the values, the range. And if you go to the report, you can also identify the internal forces that are causing the stress in the tension, stress in the compression. So these are the normal forces and the bending moment. So if you create your linear stress equation, where is the normal force divided by the area plus bending moment divided by the moment of inertia times some lever arm. So you will exactly receive the same output, like 17.2 megapascal. And here is the equation and also description. This is very helpful tool. You don't need to use it all the time. Yeah, but I would like to show you that it's here for you to understand that what is the linear stress on the beam from these loads, from this combination. What about the pre-stressing losses? I mentioned that we are supporting the construction stage analysis. And if you have a construction stage analysis, you also know the losses that are happening or taking place on the tendons. So I will go to the tendon stresses and losses. Based on the first G2 group of the tendon, this is the first group of the tendons, we put it inside. And you can see the graph of the losses. I was putting there some debonding part. It's a 2 meters. So you can see the stress, or the tendons is starting to have some stress, 2 meters from the supports on the left and on the right. The red curve is the stress after short-term losses. You can also hit all points and you exactly know how the stresses are changing over the length of the tendon. What about the long-term losses? The long-term losses, you can see what is the drop, what is the decreased stress in between the short-term and the long-term stresses. There is approximately 300 megapascals. Yeah? And if you would like to know more, you will just stretch up the window. Here are all parameters that are going to the calculation based on the Eurocode prescription. And after 1 meter, you exactly know what is the losses from the anchorage set loss. What is the anchorage, what is the losses causing by the deformation of the abutments, because these are pre-stressed structures. So the abutments, you know, from the prefa guys, that if they stressed, you know, the boxes, so there will be deformation, let's say 1 millimeter. So you can put it to the application, and it's considering also this type of the losses. What about the losses causing by the differences of the temperature? Because, you know, concrete has some temperature, steel has some temperature, and this is the loss due to differences in between the temperatures. It's 29 megapascals, yeah, and also loss due to immediate shortening of the concrete, because if you put there the pre-stressing inside, so, you know, the beam is starting or going to be deflected, and also the cross sections is rotated a little bit, so it means you will get some losses there caused by the linear elastic shortening. And it's not small, it's like 100 megapascal, yeah. So right now, if we check the stress after short-term losses, we are on this track about 1.2 gigapascal, yeah. And here are also the losses from the relaxation that already took place, or the remaining relaxation capacity. What about the long-term losses? The long-term losses, what we like bringing up to the long-term losses. So there is a creep, shrinkage, and the relaxation. And from the point of view of these three aspects, the decreasing of the stresses over the distance of the length of the beam this is the biggest portion. Yeah, it's like a 250 megapascal losses caused by creep, shrinkage, and relaxation. And this is my final stress on the tendon at the end of the design working life. And this is the ratio between the long term and the short term. So generally, you know, we or at school, if we had lessons, or the teachers or professors was mentioning, hey guys, consider from 16 till 20% of the long-term losses. And if you check the precise analysis, so they hit the point, yeah. So because there is approximately 20% losses, so you don't make a mistake if you consider 20% of the long-term losses. And here is the proof. So okay, so I finished with explanation of the pre-stressing, or how to pre-stress it with other losses, and right now we'll be approaching to, or come back to the application beam. Right now, if you exit it or go back to the application, so right now there is, in all construction stages, there will be a different stress on the tendon, and will be considered these stresses for a code check. What about the supports? In the supports, if we are, or we have selected that we are working in the 2D plane mode, so there are only 3 degrees of freedom, like a X, Z, and the rotation. And if we have a simply supported beam, that's easier, because you will just take away only the X and the Z direction, and the Z direction in this second support. So it's like a hinge support, you know, sliding at the end, because you need to put there the pre-stressing inside, so it has to be like a sliding support. Otherwise, all the forces are going to the support, and it won't be pre-stressed. What about the load cases? If you select the construction stages, so there is automatically created a 7 load cases that are permanent, and here you can see the numbering of the construction stage. So if you go step by step, right now, if I click on the pre-stressing, so you can see what are the forces. So from the tendon, there is transformed forces from the tendons to the equivalent loads that is applied to the beam. Here in the G3, there is nothing. G4 is construction stage 4. There's transport. G5, final supports. G6, superimposed load. And right now you can see this is my intensity 9 kilonewton per meter. G7, there is nothing. It's the end of this working life. And the variable loads. Yeah, the variable loads is 20 kilonewton per meter. Here are very important the permanent load groups. You don't need to change it, but what is very important are the variable loads. So if there will be some wind, snow, or whatever, you will create a new load group that you will just name it, for example, snow. You will select that it's standard or exclusive, and there you need to put there the partial factors and the Psi0, Psi1, and Psi2 factor. Yeah, we do not have the automatic selection or preparation of the combination rule. What we have is automatic creation of the combination itself. Yes, this is what we have. If you go to the combination, you will select if your combination will coming from the code provision or combination 6.10 A and B, or only from 6.10. Generally, we have a habit to use it 6.10 AB, and from the point of view of the service determined state combinations, it can be code envelope, or you can create your own linear combination. If you jump into the edit mode, you can see there are the construction stages, and in the construction stages, everything is based on the on the code. And here is also the variable loads. If you create another variable loads, you will just drag and drop from this column to any construction stages you want, because generally the software don't know where you would like to use your variable loads. It's mainly in the final stage or at the end of the design working life can be. Yeah. Okay, we have 2 questions. Last 2. It's possible to set different bond lengths for tendons from the same layer. For instance, lower the tendons. Yeah, I know what you're talking about. If you would like to set a different like debonding area, so you need to create different sets. Yeah, so in every set, you will apply the debonding length to the group. So if in the group there will be 4 tendons, all 4 tendons will have same debonding length. So you need to create, let's say, more groups. If you would like to have like in the one layer, you would like to have 4 different debonding length. So you need to create a 4 group. Yeah. Same question as above in order to, yeah. Okay, so I think I answered. Yeah, the second question is the same as the previous one. Thumbs is up. Thank you, Zori. Yeah, thank you. Okay, Christian, you're welcome. And we will continue with the modeling. So this is regarding the combination. What about the construction stage settings? From my perspective, what is very important is the end of the curing. So I will put there 5 because there is the time when the protection of the concrete is off. So there is time where the shrinkage will take place. Yeah. So I will consider in the 5th day, there will be some end of the protection and the structure will be pre-stressed. I can also calculate the nonlinear creep. What does it mean? If you go closer, so you will see some explanation. So in the code, there is a formula that enable you to calculate the nonlinear creep. What does it mean? It means that if you turn on this button, so you can skip the condition about the 45% of the FCK for quasi-permanent combination, because you are considering a nonlinear creep, so you can go up to the 60% and for characteristic combination. So this will help you a lot for this type of the beams. So if you go closer, I think there is a chapter in the code where you will find it, but it's in the Eurocode 1992.1.1. Somewhere in the beginning, there is a consideration in the material properties. There should be written, there is an equation with the exponent for calculation of the nonlinear creep. Yep. So I use that because it will help me a lot. And construction stages. If you go through construction stages, you will click on every construction stage and you can check how the boundary conditions are changing, because it's also be reflecting in the outputs, because if you're changing the support, so the static scheme is changing, and also these are the boundary conditions, how it's changing. You can just check it for your safety, and I will hit the button and run the calculation. You can see the procedure of the calculation is really fast. It takes like 30 seconds maximally for the beam like this. But what I forgot is I would like to have a code check in every construction stage. So I need to turn on all the buttons. If you, let's say, don't want to consider the storage yard or the transport, you can very easily turn it off, and there will be considered only, you can see it's hard-coded is a casting, transfer of prestressing, final supports, and end of the design working life. What is in between can be turned off by yourself or by you. So, but I would like to show you all the results. Fine. I will run it again to get the results. And we will check the reactions, deformations, and the internal forces. But what I would like to mention, these are the linear outputs. Yeah, these are right now, it's like linear or forces that are coming from the time-dependent analysis, that it's a linear calculation. Yeah. So what about the reactions? If you jump into the reactions and you will select some construction stage, let's say transfer of the prestressing, so you can select, let's say, something what is coming from the prestressing. It's 0 because it's correct. Yeah, this is from prestressing. There is no reactions. But what about the G2? These are the self weight. So this is my reaction from the self weight. But what about the storage yard? In the storage yards, there's been shifted the support, so you can read out the reactions from the load cases or from the combinations. What about the deformations? It's the same approach, Let's say I would like to see what is the deflection, the linear deflections only from the prestressing, from the prestressed force in the construction stage prestressing. I will go to the prestressing and go to the PRE and check the Z direction. So you can see this is my deflection only from this load case. If I check the G2, this is from the self weight. And if you sum it up together, you will go to the quasi-permanent combination. So you can see here is the prescription. Here in the tab are written in detail the metrics of the displacement. And this is 16.6 millimeters. If I check it at the end of the design working life, if I check it for quasi-permanent combination, so thanks to the creep, because it's very heavily prestressed. So the creep, if the structure is deflect up, so the creep is happening up. So the deflection is going up. Yeah, so it makes sense because this is the essential of the creep theory that is behind.
So we have 2 questions.
Okay. Yeah, another questions. Can you design composite sections, mixed steel, concrete? No, unfortunately, we don't have this option. We have a composite, but concrete to concrete. For for a section concrete to steel, you need to have a different code, 1994.2, I think, or 0.1, or sorry, 1992.4. And this is what we don't have. We have a composite concrete to concrete. Can we have some moment and shear diagrams? Of course, I will go ahead to this point, and I will show you. It's possible to consider thermal treatment on forming. Yeah, generally, this type of the analysis, like a heat generation analysis or something like that, where you will consider some thermal analysis, how the heat is conducting through the element. So it's not there. We do not have the analysis like this. Yeah. And Christian, I'm interested in knowing whether the software enables insertion of internal forces. Yes, from the external applications, like because we have a Beam link with the SEP 2000 ETAPS and so on. So you can export. You can have a 3D structure. You will just pick the beam. You will export it, and you have the forces in the user defined forces. So it's there. Look here in the user defined forces, it's empty. But if you go to our page, to IDEA StatiCa, and I'm not sure what software you are using, but never mind. If you go to the tutorial, go to the concrete, go to the beam. So here are the software. Let's check, I don't know, RFM. If you select the RFM, so here is the tutorial that will explain you step by step that I will select beam like this. I will export it. I have all the internal forces. I will export the internal forces from the RFM. And in the user-defined forces, sorry, it will be, or axis VM, you can see in the user-defined forces, there is LC4, and this is the bending moment from RFM or SEP 2000 or axis. So we have the option to import it from the other softwares, and it makes your life easier to, yeah. So I hope I have answered the question. Yeah, if there is another one, can mild steel reinforcement be based and perform checks considering it? For instance, for crack control or check ultimate limit state. Generally, the mild steel, you can change the properties of the rebars. I will show you where, and how it's reflected in the code check. So I think for the yeah, Bogdan, I will show you. I will show you the moment diagram. But at first, what about I would like to hit the point about the mild steel. You can change the properties of the rebars that will be reflected in the post-processing. Yes. So in the post-processing, there are some, ultimate limit state and serviceability limit states. And if you check, let's say, in the serviceability limit state, 80% of characteristic yield strength, so there will be different yield strength. So it will affect the outputs. I hope I answered. Otherwise, if you would like to have more detailed explanation, just try to elaborate your questions and send some pictures what you would like to point it out. Yeah, and from Bogdan, as is a problematic, can we see the moment diagram, IDEA StatiCa? We know we introduced the loads correctly. Okay, yeah, sure. I will just put there. I will just run the analysis and show you. Yeah, and show you the internal forces. Of course, this is the 1D element. The internal forces are essential for structural design. So I will show you how to do it. Here are the internal forces. If you go to the internal forces, let's say, and you would like to check the transfer of the prestressing, I would like to see the normal force. So you can see how the normal force only from prestressing, let's say, looks like. So this is my normal force. and I can read out the values along the length of the beam. This is my shear force only from the prestressing. Yeah, so I'm load case prestressing. But let's say check the combination. So this is my diagram for shear force. This is my diagram for bending moments in the construction stage of prestressing. But what about the end of the design working life? In the end of the design working life, I can have the envelope of the ultimate limit state, or I can envelope from the quasi-permanent combination. So you can see this is my prescription, and I can display the bending moments, the minimum and the maximum. This is my shear force. Again, the envelope characteristic combination. You can see how it's changing over the length of the beam. So this is how you can display it very easily, very straightforward. Yeah. Okay. It's weird because I cannot see. Okay, I'll calculate it. Just give me a sec. Yeah. Okay, okay. We are heading to designing of the reinforcement. Okay, so I have all the results. I've shown you how the internal forces looks like, and we are approaching to concrete design 1D. If you go to the data, in the data, you will check the combination at first. It's very essential. Otherwise, if there will be some, the other load cases will be out of the construction stages, it will tell you, hey, you need to put it inside the construction stages. From the point of view of the ultimate limit state, as a standard settings is a capacity shear torsion interaction. From the point of view of the service arbiter limit state, stress limitation, crack width. For our purposes, I will turn off the detailing, yeah, because I'm not so precise. So let me turn off this detailing check. And what about the deflections? You can run the detailed calculation of the deflections. This is different deflections than are here in the tab deformations, because the deformations are linear. And if I run this detailed calculation of the deflections, there will be considered reinforcement. There will be considered some reduction of the stiffness because of the cracks. And it will gives you some detailed overview how the structure will deformed if the section is cracked. So you can have also the option to use redistribution of the moments, reduction, limited interaction check, and also lateral stability check. This is very, for the structure that are pre-stressed, it's essential to check the lateral stability. We have the check based on the equation that is in the code. So there is very simple formula that if you compare some limits, so you're safe based on the code. But we do not have the calculation of the second order effect. Yeah, so not this type of the analysis, but we know from the statistics that these checks will cover like 80% of the structure of the standard structures that are on the real chart, which are the real structures, and yeah, it will cover that. So no worries, it's very powerful. And what about the exposure classes? Right now we are approaching to the exposure classes. Based on the exposure classes, it will affect the results a lot, because for the cracks there are different limits for chlorides, for different exposure classes, different limits. Also, there can be some decompression. You need to check the decompression for, let's say, XD3. Yeah, so you need to check it. And if you select it, it's automatically detect in the application, and the software know that this code check has to be used. Yeah, I think we have a another question. Yeah, if the external moment can be, yeah, I think Bogdan was asking if the external moment can be displayed so we can compare them with the other soft. The external moment. You mean moments from the pre-stressing, or otherwise. Yeah, okay. Yeah, from the of course, of course. Yeah, so look here in the internal forces, you would like to check the bending moment from the pre-stressing. You will go to transfer the pre-stressing. Here is PRE, and here's the bending moment. So this is my bending moment from the pre-stressing, only from pre-stressing. So on the simple structures, if you have a force that is in the tendon and you have the eccentricity, you know, it's like only force times the eccentricity, and you should reach this bending moment. If you would like to know the force, you can just turn on this normal force, or some detailed anchorage stress is in the tendon design module. Yeah, so it's there. The moment without pre-stressing, you mean the moment only from the self-weight, I suppose. So it's the G2. The G2 is moment from self-weight only. Yeah, so this is how you can check it. Okay. In some cases, due to large amount of the pre-stressing reinforcement, we have a large negative moments at the transfer, and we control this bending moment using a mild steel. Because using a mild steel in most cases, because we do not want to add top fibers pre-stressed, and it's cheaper. Generally, I think, yes, this is also the approach that can be used. But if you are using this debonded length or debonded part, and this, like, the anchorage stress is starting from some points which is different from the other pre-stressing tendons, that you are not starting from the beginning of the beam, but you're starting from some distance, so you already use this bending moment, and it's nicely see here. Yeah, so if you go to the pre-stressing, so what I can see, this is my bending moments, and you can see, because there is some debonding part, so here is this drop of that. Okay. Yeah, but I hope I a little bit answered your questions. If not, please send it via email to Zole, and he will send it to me, and we can discuss it later. Moment without pre-stressing, the ultimate limit state moment. Okay. So if you would like to have moment in the ultimate limit state without a pre-stressing, so if you go, let's say, here, and here is the ultimate limit state combination. So you can see that here is the prescription, and every combination is pre-stressing. So if you would like to create a combination without a pre-stressing, you will go to the combination rule. You will create your user-defined combinations. Let's say here, you will go through this pen. And let's say this is the combination that will be only self-weight. You need to select what construction stage you would like to use. Let's say you would like to, you will use the linear combination. It means that you need to put the partial factors. It's up to you. The type is ULS fundamental. And from the point of view of the self-weight, you will put here, let's say, 1.35. Yeah. So, and pre-stressing will be removed. Right now, you will receive the combination, and here will be, let's say, 1.5. Yeah. So it's up right now. It's up to you to create a combination, or you can stay by the code provision. And you can, if you confirm it, you will receive the combination like this, but you need to put it to the construction stages you want. So you will jump into the construction stages. Let's say I would like to put it at the end of the design working life. Go to the combination, and you will assign it. The combination is here, and you will just edit on the right side, and it will be considered in the internal forces, and you can display it. Yeah, so this is the option what you can do. Okay, I will just okay. Right now there is something being used. Perfect. I will just save it and try to I'll just turn it on. Yes. Okay, just give me a sec. I will just open it up. Okay. I'll fix the issue like this. And we will be heading to putting the reinforcement. Okay. Yeah, you're welcome, Bogdan. I hope it helped. Yeah, the application is really versatile. Yeah, so you can create so many stuff there, but okay, yeah, we are in. I hope it will be working. Yeah. Right now we were approaching to putting the reinforcement. What about the reinforcement? You know, there is not only the pre-stressed tendons, you need to put there also the mild reinforcement, how it's written in the chatter, or if I'm correct, I understand it correctly, it's a mild. It's like a standard reed bars that will be putting there. What about and how to use it? You will use the reinforcement option. We are working with so-called zones. So if you hit this button, so you can select the so many zones you want, and in every zone can be a different reinforcement. To make it like a clear and straightforward, I would like to have a same reinforcement layout over the whole zone. So I will confirm it right now, and you can see that the beam is blue, so it means that there is only one zone. If I let's say select this option, you can see the beam has been split into the different zone, different color, different zone, different reinforcement can be put to in the reinforcement editor. Just show you how it works. I will show you that right now we will make it simple. And I would like to reinforce the section. So if you hit the button on the section, I will create the stirrups. Just let me turn off all the dimensions, and the dashed lines is representing the cover. The cover can be changed here, but I would like to at first start with the stirrups. The stirrups can be like assigned by using new by the points, and I know that the stirrups will have a diameter 10, and these stirrups will be located here and will be active for shear and the torsion check. It's very essential to it's up to you like an engineer to decide what stirrup will be active for shear and the torsion. Yeah, because generally the application it's a general problem, so the application very easily don't know what stirrups will go to the shear check, what to torsion check, or both. So the distance is after 100 millimeters, and you will select the points. So you will just click on the points. You will enclose the stirrup and confirm it. Yeah, so I have a stirrup like this. Right now, I would like to put there another stirrups in the bottom and the top flange. So new from the point, the stirrups will remain the same, 10 millimeter diameter, but the torsion check will be turned off because in this part, this reinforcement won't be, or stirrup won't be active for torsion, and the distances will be after 200 millimeters. So I will select the selection and close the stirrup and confirm. Right now I have another reinforcement rebar, new from the points, and the last one is in the top. So I will select the top flange reinforcement. I will enclose the stirrup, confirm it. And from the point of view of the stirrups, it's finished. And what about the new on the edge rebars? Because there are some longitudinal bars that will like increase the bearing capacity. Yeah, that will help the cross section overcome the loads. So here is the longitudinal reinforcement, and you can put it new on the line, new on the edge, or new on the all edges. It's the same approach as for a tendon. So right now I would like to show you new on the edge, but you need to turn on the edges, the numbering. So for edge number 6, there will be diameter 16, and there will be like 4 bars in a layer. You can see it looks like this. I will just create a new on the edge. There will be a diameter 12, and I will locate it to the edge number 12. It's assign it. And the last one, I will just hit the new on the edge. It's located, you can see right now it's overlapping because the color has been changed. So there is a collision. So I would like to change the cover at the edge. The offset from the bottom edge will be 135 millimeters, 40 millimeters on the left and 40 millimeters on the right. So, and I have shifted the rebars, so that's perfect. I think I can confirm it. And you can see that the whole section has been reinforced, and also the reinforcement been adapted based on the haunch that is there. So it's like a stretched over the section. If you are using a pre-stressed structures, you as an engineer need to define a check position. It's very easy. If you don't know where to put the check position, where will be the critical moments or critical forces, you can put so many cuts after, let's say, 1 meter or after half meter. But exactly for, let's say, this beam that is simply supported, it's like a straightforward, because I would like to have 1 cut close to the support and 1 cut close or in the middle. So let's say I would like to put there in the effective depth from the beginning, it's like 600 millimeters or 800, so it will be 0.8. At the beginning, I would like to process the cut, and I would like to see there the code checks. And in the distance of 7.2 meters, or we can go closer, let's say 7.5, or exactly in the middle, there will be the maximum bending moments. You can also draw the bending moments. This is the envelopes at the end of the design working life. Here is the shear force, here is the normal force. So you can see, you can select also the combinations you would like to display, just only for your information, where the maximum spot is. Yeah, so let's say I can keep it like this. Yeah, I'm not exactly in the middle, but show you what are the results. I will check the combination and go to the detailed. Right now, all the internal forces are going to application RCS. It's a reinforced concrete section check. You can see that here are 2 sections. You can find out that here are 2 sections with all the construction stage combinations, all the days, and you will just hit and run the analysis. Okay. You can see that all code checks are passing, but there is only 1 check that is not passing. It's a transfer of the pre-stressing and from the point of view of the stress limitations. So if you go to the results, go to the stress limitation, you exactly know what is happening. Here, the limit for characteristic combination supremum is 14.8 megapascal. But the stress in the bottom is 16.5. So it's in the 5 days of the concrete, there is, the strength is increasing over the time. But in the 5 day, there is a limit 0.6 FCK in the time, which is dependent on the T. So it's a different limit than at the end of the design working life, that the value will be different. But right now, there is so much pre-stressing that it's like overstressed. So we have, let's say, three options. We can come back and increase the grade of the concrete. Yeah, so it's a C35/45. We can also decrease the anchorage stress, because right now there is 1.4 gigapascal. Or we can put there, let's say, more reinforcement that will cover also some portion of the stresses. There is more options that can be used because we are 11% over. So right now, let's say what I can do, I can come back to load cases, go to design, come back to the tendons, and I will decrease the anchorage stress. Yeah, so it will just take a second and we will see if it helps or not. Yeah, so there is like this. Ouch. 1.3. Maybe it will help. So we'll see. Yep. So you will just hit the button, run the analysis again, and I think we will get the results very quickly. Okay. If it won't help, there will be some issue. It's never mind. But very important is the workflow. Yeah, how you can process it. I will run the analysis again. Yeah, you can see it helped. The utilization is 92.8. So all the results are passing. And I would like to show you how the results looks. Yeah, so I would like to show you what is, let's say, in the section 7.5 meter from the end. So at the end of the design working life. So go to the results. If you go to the results, what you can see, you can see some capacity. This is the standard interaction diagram where you have a green cross, so you're inside the curve, you're safe. What about the shear? In the shear, the software automatically detects the minimal width and tells you and gives you all the design forces and also all the resistance forces and the inputs that are very important for the equations. If you use the equation from the code, you can use these inputs and you will receive the same response. What about the torsion? If you can see for torsion, there is no torsion moment or no torsion action. So, but what is very important for torsion is important the creation of the equivalent thin wall section is developed correctly because we correctly assigned the stirrup that it's active for torsion. What about the interaction? Right now it's more straightforward. You will see the strain and the stress distribution over the section. You can see at the end of the design working life for interaction of all internal forces, you can see that the section is fully pre-stressed. So there are no cracks also for ultimate limit state combination. So if you check, let's say, the 3D presentation of the results or 3D forces to get the equilibrium, so you exactly know what are the forces in the tension and what are the forces in the compression. You can also jump into the diagram and, let's say, hit the fiber and you exactly know where you are on the diagram. Or you can hit the rebar, or this is not a rebar, this is the pre-stress tendon. So you exactly know what is the vestigial resistance, or where are you from the point of view pre-stressing. Yeah, so you're still on the elasticity. There is no plasticity that be employed. So also for rebars, yeah, for mild rebar, or for rebar, sorry. So you exactly know where you are. You are under compression 90 megapascal, and here is also the relevant strain. This is what you can expect. What about the stress limitation? In the stress limitation, you can see the distribution over the section, also the maximum stresses in the compression and in the tension for pre-stress tendons, and all relevant checks. Yeah, also for prestressing for concrete, and the critical one. The critical one is for tendon number 5. So if you assign the numbering of the tendons, so this is my critical point, critical tendon that is there, 946.4. So this is my critical check, utilization 68%. What about the crack width? Based on the fact that the structure is really well prestressed, so there is no need to check, or no need. There are no cracks. There are no cracks. Just very easily to say there is no cracks because it's fully prestressed, and this is what we want from the prestressed structures. This is the benefit. This is the additional value of the prestressed structures, that you can play around with the prestressing to capture these effects and prevent creation and propagation of the cracks. And what about the response? The response is the ultimate limit state normal forces on the section itself. So it means it's better overview of the combination than in the capacity. It's like a different point of view, and you exactly know that what forces is taken over by the concrete, by the reinforcement in the compression tendons, and you will see this is the equilibrium. This is the total force that is there, and you exactly know what is happening on the section. I can see some messages in the chat. Can you check for bursting, spalling, or spitting at the encouraged zone? In this application note, I will show you how you can check these areas in the application IDEA StatiCa Detail. In this zone, in this Beam module, it's not possible. It was a question from Adrian. Can you check for bustling, spalling, and splitting in the encouraged zone of a member? How can we know which is the value of the moment that causes the beam to be decompressed at the bottom flange? So generally, in the crack width, you can see this is the decompression limit. This is my combination, which is frequent combination, infimum, supremum. But you are here, if you jump in here and go closer, so here is the description of the combination that is used. So if you can read out the prescription very easily here. But what is very important, you exactly know what are the forces in the section. So you can take the forces and, let's say, calculate it by hand if you do not trust or you would like to verify it. So this is the option. Why the default value of strut angle is 45 instead of 21.8, sorry. Can strut angle can be automatically optimized starting from 21.8? Yes. We as a default consider or have a settings 45. So this is our assumption, what we consider. But if you run this strut optimization option, so it will gives you, if the structure is, let's say, if the stirrups are overloaded, and you will run this analysis, so the inclination will be 21.8. So it means more forces, it will be going to longitudinal rebars, and it will help the structure to overcome the load, and the checks will be passing. So you can also put it by hand 21.8, hit the enter, and you will get the results based on this angle. So this is the procedure you can use. As a default, we consider 45. This is our settings. Okay, so I will go. I think we finished this part. I didn't show, sorry, I didn't show the lateral stability. This is very essential from my point of view. So what about the lateral stability? Right now, if you would like to check the structure based on the lateral stability, so the B0 is, you need to put the flange width in if you go closer, here is written width of compression flange according to clause 5.9. So there is 0.5. The H is 1.2, and the L0 is 16. If you go closer, you can see that the limit L0T divided by B is 32, limit is 37.35, and also the limits between height and width is 2.4 calculated, and limit is 2.5. So it's passing for this persistent situation. If you copy that and just switch it to a transient, there is also some not so strict limits. So it's also passing. So right now I have checked the beam based on the Eurocode formula, and it's passing. Yep. Right now, let's go to the results. Yeah, and I will run the calculation, show you the deflection. Yeah, there is the question, so we can answer. Can this be edit code settings for the future? Sure, yeah, you can create your own settings in the code and upload your settings to the application. Yeah, that you will usually start with the 21.8. It's possible, Nicholas. Okay, so we can see it takes some time, but I would like to show you the deflection. In the load history, you can see some schematic interpretation, how we consider the immediate deflection, long-term deflection, some increment based on the creep. I think we are running the time, so I will show you only how it looks because I would like to move forward to the detail application. So in the deflection, you can select that if you want the linear, immediate, long-term, and the total. For us, it's essentially the total because this is the summation of the previous one, and you can also check the stiffness. You can see that how the stiffness is increasing because there are no cracks over the construction stages, or let's say in this specific stage. Yeah. If there is a crack, there is a drop of the stiffness, and it will affect the calculation of the deflections because there is bending stiffness there, so it will be affected based on the cracks that is like leading to different tension stiffening, and based on the reinforcement that is there. So also the reinforcement which is there is affecting or is going to affect the deflections a lot. So this is my total deflections at the end of the design working life. And if you would like to check the increment, so this is my increment from the creep, and this is the total deflection, 19.2 millimeters. Yeah, so this is at the end of the design working life. If you would like to check the combinations, let's say in the prestressing, so this is, you can see this is my deflection. Sorry that we are running out of the time, so I would like to show you the export to IDEA StatiCa Detail. Is it possible to design different tendon heights along the length of the element? To assign different tendon heights. I think I do not understand the question. So if you can send some screen or some drawings on the paper to clarify it from my side, I will answer. But right now I don't. Sorry, I don't know, Mohammed. Okay, so what about the report? If you go to report, you can customize it. You can, on the right side there is a property grid, and you can customize it. Okay, you can customize it. And here you can see the report with all the preferences, all the load cases, all the combinations, all the outputs. It can be, of course, extended. It can be more robust. This more information can be inside you, or it can be more brief if you want. Yeah, so it's up to you to customize it. This is some default default settings. So I suggest to have like a maximally 5-minute breaks, and we'll be in 5 minutes, we will be focusing on the export of the beam and putting the openings and the final project. So thank you, and we will see in five minutes. So welcome back. Let me continue on the other part, that will be the export of the beam and putting the openings. So let's go directly to the export. So if you go to the reinforcement option, here is the export to the detail. If you hit the button, so you can export part of the structure or the whole structure to IDEA StatiCa Detail. So that's very important to select what construction stages you would like to export. Generally, for the purpose, you can export, transfer the prestressing and the end of the design working life, but I will select, or yeah, I have selected already the last one, and I would like to import the whole beam. So it means what we are doing from the internal forces, we are deriving the external loads. So I will show you how it looks. You will go to the next step, and you have the option to export load cases and the combinations. If you have a reinforced concrete structure, I strongly recommend to export the combinations. But if you have a pre-stressed structures, I recommend to export permanent and the variable loads, but not the pre-stressing one, because I will put the pre-stressing there, because there we are not exporting the tendons. The tendons have to be, if you are using a beam link, the tendons have to be used in the applications. Or the other option is to export the combinations. There will not be any tendon, but there will be the forces from the tendons. Yeah, and the forces, of course, will be different for transfer of the pre-stressing, and will be different for end of the design working life. So I would like to show you the process where I will be putting the pre-stressed tendons inside the application IDEA StatiCa Detail, but I would like to export the sulfate. There is a G6, it's like a superimposed dead load, and Q, it's a variable loads. So I will finish it, and you will see that the external load is exactly the same as in the application IDEA StatiCa Beam, because it's derived from the internal forces. So there is some numerical derivation that will tells you or show you how the loads looks. So that's very helpful. Okay. So it's exporting, so it takes some time. You can see the application is running, and I have a same geometry, same boundary conditions, and what we'll be doing right now, I will just rechange or switch the boundary conditions for, from my perspective, better one for this model, and show you how to put the reinforcement. You can see the structure, or the software is telling you that the distributed point supports are not connecting over the full length. So just let me turn off or delete this support. I will put there another one. If you go to the model entity, here is the line support. The line support, as a default, the line support is inactive in the tangent. So I will represent using this support the the hinge that will be there. Yeah. So, but it will be located only to the part of the bottom edge. So the part of the bottom edge is 0.2 meters. Yeah. So this is my support that is located here. It's like a fixed support, but if there will be some rotation, this part, you can see there is like a rotation point, and if there will be some tension, it's inactive because it's a non-linear support in a tension. Yeah, this is how you can model the hinges. Right now, we have a model that is composed from the, let's say, 3 walls. Yep. So be careful. It's a wall model. It's not a 1D beam element. So I will copy this operation. I will just change. I will like release it in the longitudinal direction and measure it from the end, but from the member M2. You can see I have created very swiftly the loads, the boundary conditions. But what about the loads? If you turn on the loads, you can see this is the loads from the self weight. This is the loads from the variable, from the superimposed dead loads, 9 kilonewton. This is 20 kilonewton. So as you can see, it's the same value as is in the IDEA StatiCa Beam. And what is missing is the pre-stressing. So I will create a new load case. You create new load case that you need to assign it like a pre-stressing, and there will be nothing because the pre-stressing, I will just go here, rename it for pre-stressing, just pre-stressing. And right now, the software knows that this load case is suitable for putting the reinforcement tendons, for reinforced tendons. For tendons. What about, because we have all 3 combination or all 4 load cases assigned, right now we need to prepare the combination rule. So if you go to the combination, so I will create a 3 combination that, 4 combination. The first combination will be for ultimate limit state, second one also, third one will be for characteristic combination, and the fourth one will be for quasi-permanent combination. So what about the combination rule? So I know that the pre-stressing, the G2 is a self-weight. So for permanent load, there will be 1.35, 1.35, 1.5, and pre-stressing is with the factor 1. For long-term losses in the ultimate limit state, I will consider 20% of the like the decrease of the stresses. Yeah, so here I will put here 0.8. For for G2 it will be the same, 1.35, 1.35, and 1.5. For characteristic combination, I will not be playing around with the pre-stressing factor because everything will be set up in the for a tendon or in the tendon design. So it's not necessary to play around with the factor because there will be, for serviceable determinate state combinations, there is option to set up the calculation of the long-term loss, not the long-term, but the short-term, and the long-term losses are put it somewhere else. Yeah, so I will keep it like this, and here 0.6. So this is my just a combination that I have created. Of course, you can have a different prescription, but only for demonstration, I will keep it like this. You can see that's been increased, and we will approach to assigning the openings because we forgot to put there the openings. Give me a sec. I will just open up my model that is here. You know what are the diameters? You know, Okay. Yeah, it's here. Okay. So, if you have a load, right now we will put there the openings. And you can see the opening if I hit the button. So the opening can be rectangular, can be circular, or it can be polygon, that you can import whatever shape you want. I would like to have a circular shape. I hope it will appear quickly because I don't know the diameter, but the diameter, I think it will be 0.5 and it will be located in the middle of the beam. So I will use the master point 6, and you can see I have created the opening that is exactly in the middle of the beam. But I would like to have more than one opening. So it's sorry, it's final model. I need to know the openings. Okay, it's a 0.4. My bad. 0.4. And there will be like 5 openings as a total. So I will copy this operation. I will just shift it about the 2 meters on the left, or sorry, on the right, or just copy the operation again. 2 meters on the left, copy operation again. 4 meters on the right, copy the operation again, and 4 meters on the left. So I have created the openings, and right now what you need to do, I will put there the pre-stress tendons, yeah, because the pre-stress tendons are missing, but the load case is there, and I need to filling out all the parameters for pre-stress tendons. They are straight, so it's very easy to handle, but you can also import the tendons. If there is a complicated geometry, you can import the tendons from the DXF. Yeah, so it's more than welcome to import the tendons from the DXF preference, because it's like squeeze your time for insertion of the complicated geometry. So what about the tendons? Tendons are hidden behind the rebar assembly part. So you can see that there is a pre-stressed tendons. You can select if the tendons will be pre-tangent or will be post-tangent. So for our case, it's a pre-tangent tendons. So yes, where it is. Okay, I will come back here, and here is the pre-stressed tendons. So this is my material properties. You will go through this library. You can see there is really rich library of the tendons we used. We have to select the same as in the Beam application. And I would like to show you how it looks in the 3D. The tendons has a gray color. So I would like to have a pre-tangent tendons. There are 4 bars or 4 tendons in a layer. The long-term losses will be 20%, and the master point, if you will use the putting or assigning the tendons inside the section, so you will select the master point and the insert point. This is what we are using. So master point 1 and the insert point is M2. Okay, so as you can see, sorry, M1 will be here. So my first point is master point 1. The stress is, this is the stress after short-term losses, except the stress from the elastic shortening. Yeah, so you will go to IDEA StatiCa Beam. You can read out the values from the tab, from the tendon, and put it here. So let's say here it's I think it's a 390 or 1390 megapascals, and the Z direction, because the cover is 50 millimeters from from the bottom. Yep. Say 50 millimeters from the left, something like that. And right now I need to position it on the right side. So it's like a master point 2. The X is 0. There will be the X direction is -50 and the Z is 50. And I have prepared the tendon layout with initial stress or with the stress after short-term stresses, short-term losses, 1,390 megapascal. So this is how it looks. This is my consideration of the long-term losses, because at this application is not, there is missing time-dependent analysis, but it's not so important to have it here because you exactly know the stresses from the application Beam. So, and right now I would like to copy this operation in the same way, and I will just change the Z direction on the 100 and the 100. But you know, in the application IDEA StatiCa Beam, we have some debonded part for these tendons. So how to do it? How to do it? How you can do it here in the application? We just change the length of the tendon itself. So it's very easy. You don't put here 50, but 2000 and -2000. You can see, and I have created the same layout as in the application IDEA StatiCa Beam. So right now I have a tendons and I need to put the reinforcement layout. Let's generate to speed up the operation because we are running out of the time a little bit. So I will show you how the model looks like, the final model, with the reinforcement, and show you the presentation of the results, because it will be better, and I don't want you to bother with putting the reinforcement inside. So this is the same model, you can see, same combination, but what I have there is reinforcement. What is very important, that the reinforcement can be imported from the DXF, or you can do it, the reinforcement like this, very quickly by using only 6 operations. Yeah, 6 operations for stirrups and 2 for group of the bars. So you can very easily check your 3D rendering of the beam and see how it looks.
Lukasz, maybe I don't want to bother you. Maybe you can show for the attendees from where they can download all these files, and where is prepared all the where are all these materials, and from where can they download the trial version of the software?
Sure, I can do it. I think Thomas has created a page. I will send it to you. Give me a second, because there are all materials which I'm showing right now. You can save it and use it and check it. Just give me a sec. I will give me a sec. I will send you the link. Yeah. Okay, so give me. So 2 months. Yeah, here is the page. I will just log in and send it to you, this preview where you can download it. Yeah. I forgot to do it. So okay. Yeah, it's preview, perfect. Like this. So I hope it will be working. It's a Zoom, right? So here is a chat. Here. So please, here is the page. What is it? It's not working. This? Okay, perfect. Yeah. So everybody has access to the page where if you go in, so you have, I will show you here. Yeah, it's here. Ah, okay. Yeah, Zoli has sent the link to the chat. So you can check it there. Sorry, it's here. Yeah, you can see here is a morning session. So it's for you. If you save it, there is a morning section, programs and all the examples which I went through, and you can open it up and you can use it. Of course, you can download also the afternoon session, but it will be holding by Thomas, and it's not the content of this session for the morning. Okay, fine. Yeah, and yeah, just please give me a sec. Yes, yeah, of course. There is a question from Adrian. Can you check for bustling, spalling, and splitting in the anchorage zone of a member at the end of the beam? Of course, I will show you the results right now, and there is because this is a 2D model, so there is the option to check it, because you will see some redistribution of the stresses, and the concrete will be checked in the compression, and also the tensile forces will be covered. So the spalling is captured there. Yeah, so this is the questions. Thank you for informing me. Sorry. Thank you for that. Yeah, and there is also, yeah, I think we answered the Adrian question, and there is another question. I noticed that you inputted the partial coefficient for pre-stressing at ultimate limit state as 1. Does the program automatically gradually remove the pre-stressed when the tendons start yielding? Generally there is a condition in the code. There is a condition in the code that capture the stress limit of the tendon. And what about if you check the material properties of the tendon or material diagram, so you can see if it's starting to yielding, we are checking this area, and here it stopped, and you are over if this limit is exceeded. So maybe this is the answer on your question. And let me show you the results. Okay, so I will run the calculation. I hope it will get it very, very quickly. Yeah, so it's 11 minutes to go. So right now we have some like 2 minutes where you can put down your question, and we will answer it. So I hope I answered the question for Nicholas. Yeah. And yeah, and later on there is the part that is dedicating to 3D concrete. There are 2 fantastic videos that will show you the power of the application, and what you can expecting from the version 24. And I think you will be really, really surprised what type of structure you can handle there.
The launch of the version from which they can try it, because if they download today, it's not.
Yeah, it's the version is not on the web today, but will be released in 1 or 2 weeks. I don't know exactly the time. 24th in 24, yeah, in 24 of April. Yeah, so in 2 days, let's say. So I hope we will get the results really quick. Really. Yeah, so before we get the results, so let me jump into the 3D concrete and show you what are the new features of version 24 and what you can expect. So I will show you this. So I'm not sure if you're aware that we have an application, maybe some of you know, some of you don't know, but we have an application IDEA StatiCa Detail that is focusing on connection design for concrete to steel connection, connection to connection, steel to steel connection. But generally the footing is problematic everywhere. Yeah, because right now in this application, IDEA StatiCa connection, we are not able to put the reinforcement because the model doesn't allow it. But it's a little bit problem because the people are asking, hey, how it will be working with reinforced concrete block. And we have a solution right now. The solution, if I will show you, you have a connection, you will run the connection, you have the outputs. And right now you can see that there is some problem with some splitting and some concrete cone failure. So you can export to IDEA StatiCa 3D Detail, put the reinforcement there. You will run the analysis and you will get the code check in the 3D space. So this is like a big step into the future that you can analyze and use the process and the workflow between IDEA StatiCa connection and IDEA StatiCa 3D house for in-house solution. Yeah, we have it in-house, so we are supporting this BIM link. We are fixing the bugs and so on. So this is really big step forward for analyzing, design, and code check every shape of the anchorage block, which different modification of the reinforcement that is inside. And also we are capturing the failure modes like pulling out of the concrete cone, yeah, or pulling out of the rebars or anchorage outside from the concrete block. So everything is captured there. Right now we are handling ultimate limit state, and later on, after some months, we will be focusing. Yeah, and after some verification and the validation, we will focusing on the serviceability limit states. So I hope you liked this introduction about that. And I have another surprise for you. And this is how you can design and code check 3D anchoring in the application IDEA StatiCa Detail. So this is the process. So you know this application right now, you will select the 3D and 3D solid block. So you will set up the parameters and put there the boundary conditions. The boundary conditions you can right now like model, let's say the pile cap, or there can be, let's say 4 piles. You will use a copy and paste from the Excel spreadsheets and create some nonlinear supports that are representing the piles. You will put there some column with a base plate. You will put there the anchors that are inside the concrete mass, and also put there some compression force from the bending of the steel element or the steel I section. You will put there the forces that are acting in the tension. Also, everything what is under compression can be inserted from the using copy paste from the Excel spreadsheet. You will very quickly reinforce this region with reinforcement that is spatial, so it will be like, acting in all directions. You will create a combination for ultimate limit state. You will run the analysis. You will receive the results, and these are the outputs. So right now you can see the stress, the principal stress in the compression, but the 3D stresses, yeah. So there are 3 tensors of the principal stresses. These are some deformations on the concrete block, and you can see these are some 3 directions of the principal stresses. You will generate the report where everything is set up and prepared for the production. So this is how it looks for 3D concrete. So you can looking forward in the version 24, there will be a beta, and after some time, if we verify the solution completely, it will be out of the beta. I will check if we getting the results. Yes, we are in the last combination, and we will see. You can see there is more reinforcement. It takes like longer time, but you need to understand that that's a completely material nonlinear analysis. So you know, there is so many increments, so many iterations. So I will be receiving the results in a minute and show you how it looks. Okay, so we are getting the results. You want to say something? Okay. So guys, just a minute. You have 3 minutes or 4 minutes left for this seminar. So I will go very swiftly through the results and show you what are the stresses in the tendons, how the structure is deforming. Yeah, what are the stress concentration around the openings, how the stress is going to increase, because there is, you know, there is a stress concentration, there is a concentration factor around the openings that cannot be captured in the 1D element solution for like a beam theory. And also how the reinforcement is utilized. So you will also see that there is like a real decompression, because, you know, we do not accept the concrete in the tension. Yeah, right now, this is the pre-assumption is that we neglect the concrete in the tension. So this is the essential condition for this application, which is code compliant. So, okay. So guys, if you want, you can just drop into the message window some question, and we can, let's say, come back to something and answer. Yeah. Are you going to yeah, there is a question. There is the question from Nikolaus. Are you going to develop software for Eurocode 1993 and Eurocode 1994? 1993, it's a steel. Yeah, it's a steel. Yeah, so we have maybe I can show you the application, what we have. Based on that, we have application that is called IDEA StatiCa member. If you go to steel, so here is a member design. And this is the application that is using the power of the connection application, because you will create the simple frame or some complicated frame or some structures that are susceptible on the losing of the stability. And there are the shell elements, and we are supporting that there Eurocode 1993, because there are, you know, the conditions are coming from the Eurocode 1993. And 1994, these are the composites, right? So these are the composites, concrete to steel. Actually, right now, we do not have it. We don't have it in the plan to develop this code, but you never know if let's say in next year we will decide to create something like that. But for the plan to this year, it's not there. Mhm. So, okay. I would like to also inform you that we have a free platform, like a free education platform that it's called Campus. If you just go here, go to the support center, and here is e-learning and the certification. There are courses for steel and the concrete design. So if you select like the essentials of concrete of steel connection or advanced topic in steel connections, structure design and stability of sensitive members for lateral torsional buckling and many more. Or for concrete, there are a structure design of RC elements with discontinuity regions. This is generally our case, what we are doing right now. And also the pre-stressed option. This is the beam from the training that you will go through the course and you will understand the benefits, the impact, and how to design and co-check the pre-stressed beams and pre-stressed structures using IDEA StatiCa Detail. And there is also the course for structure design of reinforced concrete sections. So you can use it because this is I have shown you this workflow because there is a beam application and RCS. Right now I have a results, guys. I have a results, and you can see that all results are passing, and we can check some detailed results. On the left side, there is a summary overview of all results, and you can see that there is another part, and this is a tendon with the utilization of the tendon, approximately 80%. What about the strength? If you check the strength, I will turn off the rebars and show you sigma C and also the mesh. You can see that the mesh is really fine, and also the mesh around the openings is uniform. It's very important because here you can see has been increased the stress because of the concentration of the stresses. So you can see how the stress float is running over and fluiding through the openings. Yeah, you can also check the directions. It's in the vector form. It's nice to see how the concentration stresses is happening. What about the reinforcement? Like for reinforcement, there is the stress. If you check the stress, it's, I would say, the maximum stress is 324. So we are still on the elastic branch, and you can see that the stress is mainly on the stirrups. Why? Because if you pre-stress it, so here is a pre-stressed force, and the transverse force is going mainly to the stirrups. So the longitudinal rebars are not so utilized because it's pre-stressed. Yeah, so there is a big portion is in the stirrups. You will see that on the cracks that there are no cracks on the structure, but there is a crack in the web because there is a big transfer strains. Yeah, so it cannot be captured in the beam application. So what about the tendon? What about the tendon? You can see this is my stress, and also at the beginning you can see some Hertz effect. So it's starting from 0 and increasing the stresses to fully bond this part, and later on it's fully anchored, and you can consider like the full strength of the tendon. This is the stress. What about the stress limitations? In the stress limitations, we are giving you the information that the tendon is with a small portion there is a very small portion of the tendon. So there is a decompression check that can be turned off. Yeah, if you don't want it, you will go here, and here is neglect decompression check, and you will just turn it on, and it's neglected. Yeah. Here is written that some parts of the tendons lies outside the concrete in compression. Here is really small portion of the tendon. And why? Because there are openings. There is a reduction of the stiffnesses, and it's been redistributed, and you will getting a little bit different results. than in the application IDEA StatiCa Beam that are more precise. What about the cracks? The cracks, you can see that the cracks will be presented in the web or on the web of the structure, but the cracks has a really low magnitude, because 0.054 is the maximum crack, but I would like to show you the cracks on the model, so it's rendered. So give me a sec. Yeah, you can see maximal crack is here, but what's the location? The location or the distribution direction of the cracks is almost perpendicular to the stirrup. So because of the transverse tensile strain in this direction, there will appear some cracks which cannot be captured in the beam application for that are forming in this way. What about the deflections? Of course, deflections, it's also good to see the deformed shape. What are deflections? 9.6 millimeters, like the long-term deflections. That's it. The report, you can print it out, the report. The steps are the same as for the first example. And I think from my perspective, that's all. I will pass the word to Zoli, and that's all from my side. Thank you for attention.